Hello everyone. In this video we will work on a machine learning project. We will train a machine learning model with our sample dataset, training dataset, and we will test its performance uh, by actually testing the prediction of the model we have trained. So let's go ahead and check on our data file actually. So here we will work with a data file, CSV file. So first we load the required libraries. Load numpy, and we will use scikit-learn. So model selection, train, test, split. So and from scikit-learn dot linear model import logistic regression. So we will use logistic regression model to train our dataset from scikit-learn dot metrics import accuracy score. So the metrics from scikit-learn will help us to measure the accuracy score of our prediction model. So it will be a binary prediction model, and the logistic regression is eligible for this. So next we should just run this one time, and after loading this we go to our next phase, that is the data collection and preparation phase. And processing. So into our pandas data frame we load the file and we have to input a parameter here that is mentioning the file does not have a header. So why we are putting this parameter, I will explain. So if we have a look in the actual physical file, we do not have a header. We just have the comma separated values. We do not have a header. So from here it is difficult to see, but once we print out the data, here we will be able to see the actual data. For example, if we run data frame.head, so just run this code. Okay, so here we see first 5 lines. So here we see there is no headers in our current data set, but this will not be a problem because we actually need the features, not the column headers are not actually mandatory. So at the last column, the 60th column, we see the labels and the labels are of two category. One is rock and one is mine. So we will keep the 60th column for our for labeling our model, and for training our model we will use the remaining set of the columns. So for example, for a given set of data till 59th column, our model has to predict the result perfectly from a, from a rock versus a mine. So we will proceed forward to our next step, that is data and label. So we have to separate the data and label and show our machine learning model, which is our training data set and which is our test data set. So let's move forward to our next level. Okay, so in this phase we separate our data and label. So we divide our actual data set into two partitions. Separate data and label. So in X we will keep data frame, drop columns is equal 60, axis is equal 1, and this code is marks 0 to 59th, column 4 as training data. So all our training data are stored in X variable. So in Y variable we keep only the last column, mark the 60th column. Okay, so we are dropping column number 60 and going downwards by x is equal 1 and storing all the remaining columns in X, and in Y we just keeping the 60th column to label the data. Okay, so in the next step we have to execute this. Okay, there is, okay, this is DF, spelling mistake. So okay, in our next step we have to divide the data set between training dataset and test dataset by using our train, test and split. Okay, so let's do it. So divide original dataset between training and test dataset. So, and for that purpose let's have a look at our actual data size. So we can see our actual data size by div.shape. So if we run this code, we will have an idea about our total size of our data frame. That is, we have 208 rows and total 61 column. So 208 rows is not very big data, not very large number of data, so it's a comparatively small data set. So in that case we will try to allocate 10% of our total data for testing purpose. So we will allocate 10% as testing data set. Okay, so next declare the actual allocation x train and x test and y train and y test. Okay, so there is no spelling error, and we have to call the function train test split, and we have to mention x y from the original data set. Test size is equal 0.1, since it's a 10%, stratify is equal y, and random state is equal 1. Okay, so next go to our next step. Let's going to our next step. Let's see how this code actually works. So here we will try to compare the dimensions, since we have already divided our main data set to training data and test data. So we will try to see the shape and or the size of data set we get after making the division. For example, we can just print x dot shape and x train dot shape. This will be interesting. So x test dot shape. So now if we execute this, we can see this is the original dimension of our original data set, and this is the dimension of our training data set, since we here mentioned uh, in this function to split the data set actually and allocate 10% of the original data set for testing. So this x test dot shape is returning this, and this means that 10% data it has been allocated for testing purpose, and remaining 90% for test for training purpose. So yeah, in this stage we should move to our next step, and that will be on performing the actual work with our model. For example, for this purpose we create a new block of code. Okay, so here we will train the model with logistic regression. So now model equals logistic regression. Okay, so this is no spelling mistake for logistic regression. I just copy this and paste it here. Okay, so our model is ready. Let's do the fitting thing. Model dot fit, and the parameters should be x train comma y train. Okay, so now execute this code. Okay, so the logistic regression has been done, and now next stage we will go to evaluation phase. So we will first check the accuracy on training data, and later on we will test the accuracy, the prediction accuracy on the test data. So keep in mind that the training data set, it has been already the model has been already trained on the training data set, so the prediction accuracy should be a bit higher, whereas when we will compare the prediction accuracy against our test data set, it should be slightly lower, because those data set our model has never seen. So let's do it by code. So this phase is evaluation, and measure accuracy on training data. So we declare a variable called xtrain prediction. So model dot predict, and input as xtrain. So next we calculate the accuracy. So training data accuracy is equal, so accuracy score. So accuracy score, we will be using this function from scikit-learn's matrix. So accuracy score. Okay, so to compare the accuracy score, so the parameters should be x train prediction compare with y train. So remember that y train is the label. So here it's doing the measuring the accuracy exactly. Now we will print the result, training data accuracy. Okay, so training data accuracy, let's see the training data accuracy. Okay, so let's execute the code. Yes, the training data accuracy is 83%. So it's a nice accuracy. Now we should move to compare the accuracy against a test dataset. So far we have compared the accuracy against the training dataset which the model has already seen. Now we will measure the accuracy against test data which our model has not seen yet. So the title is accuracy on test dataset. Okay, so variable name should be x test prediction. So model dot predict x test, and it should be test data accuracy. We will again call the same function accuracy score, and inside we will pass the x test prediction comma y test. So yes, y test, y x test prediction, everything is accurate, no spelling mistake. So now we try to print the result. Print test data accuracy. Here we will print the test data accuracy. So now we execute this, and yes, our result is not bad, 76% accuracy. So for the training dataset we get 83%, and for the test dataset which our model has never seen, it is predicting data with 76% accuracy. So, and now we move to our final stage to actually pick a random data from our CSV file, and with the help of numpy library we reshape it to actually feed into our model and test the accuracy. So let's do it. Okay, so here we declare a variable for input data is equal, here we have to choose any kind of data. This seems confusing because this is a basically a text reader. Here if we see our values, uh, so we can pick any row depending, or because the results are binary, either it has to be rock or either it has to be uh, mine. So R for rock and M for mine. For example, if we search for M, it will show us M value. So if we choose this record, This is difficult to identify records, but I can easily distinguish. So up to this, if we select up to this selection will work for this M here. So this M will be the result, and for this input. So let's copy this and go to our notebook. So this is the input data, and okay, our input data we have to reshape, and we have to transform our input data into a numpy array. So let's declare a variable. So numpy dot as array input data, and this is called reshaping the array. Okay, so and array reshaped is equal and array dot reshape to put 1 minus 1, and for actual prediction we have to write p model. So p is just storing the value of the prediction. Model dot predict, here we are performing our actual prediction with our model. So n array reshape, we have to feed this, and finally we just print the result. And let's see, remember it has to print M, so let's check the actual result whether it should print M or not. After execution we see that it is not accurate in this case. So let's pick another data, for example this data. So okay, so let's see in this case if it can predict the accurate data. We replace the values, and in this case it should respond with M. So still showing R. So okay, so let's try another. Now it's predicting M. So our machine learning model is not always accurate, so it has 76% accuracy. So if we randomly test it 10 times with any random value, it should be predicting 7 times at least the expected result, and remaining 3 times or 4 times it should fail to predict the expected outcome. For example, if we try to predict one row with R value, for example this one, if we consider checking, it should predict R. Okay, let's see. Okay, so let's execute. See, it's predicting M. So if we run this again, it's still predicting M, so it's not working as expected, but let's try another row. and this row the result should be R. So let's check. Yes, so this time it is predicting exactly the accurate answer. So the conclusion is that considering our small data set and the 76% accuracy, it's not very much impressive. So the model has scope for improvement, a lot of scopes for improvement. For example, we have to perform some feature engineering maybe, and maybe we can do more and more some research and maybe some creating some new features by exploring the correlations between data and between columns and other and adopting other machine learning improvement techniques if we adopt. So this can lead us to be able to improve our machine learning model to improve the accuracy for test data. So when we will be able to increase the model's performance against test data, so the results should be becoming more and more predictive with real world correct prediction. So that's it for this project. Thank you.